Good morning, everyone. It's, 8:30 in Montreal, and it's 5:30 here in San Francisco, so I'm probably still asleep while you're watching this presentation. This afternoon, or today, I have a pretty full schedule at Java 1. At 8:30, I'll be going to see a presentation called JavaFX Jumpstart. Second presentation will be on Agile, called Agility with a Fresh Perspective. Third presentation of the day is JavaFX, Performance and Memory. And then the final presentation looks at how the application for iOS and Android was developed using standard Java and having it cross-compiled to the appropriate operating system. So I've got a busy day, and actually so do you, as we begin by looking at JDBC. Now I know you did JDBC last term in your database course, so think of this as a review. At the same time, you'll learn some of the techniques and approaches that I wish you to use in our course. So let's get going and find out what's going on here. So what does JDBC do? Well, as you can see, it makes it possible to do three things: establish a connection with a database, send SQL statements, and finally, process the results. In this chart, we get a sense of the relationship between JDBC and our application. So up there at the top, there's our application. It in turn interacts with what's called the JDBC Driver Manager. And the Driver Manager is what we also refer to as the JavaFX.SQL library. The manager is primarily an interface. There is very little code in this layer of the application, and that's because the various types of database applications, whether it's Oracle or MySQL or Microsoft, all use different protocols, different languages, different techniques for communicating. Therefore, to use any of these databases, we have to use the appropriate driver. In the early days of Java, there were 4 different types of drivers. They still all exist. For instance, the first one on the left, JDBC ODBC, allowed Java to connect with an older technology for managing relational databases. The second one, called Native Protocol Partly Java, well, here is a driver that not only had a Java component, but likely had a component written in another language, possibly a C or C++. This driver was initially considered the fastest type of driver if you were out or interested in absolute performance. However, as the Java language itself and the JVM has gotten better and better at what it does, it's no longer the speed demon, and we rarely see it. The next protocol, the Net Protocol All Java driver, well, this tells us it's all Java, and that's significant because the first 2 protocols require additional code that's tied to a particular operating system, a particular system. So you cannot use a Native Protocol Partly Java driver for or on different platforms. You could not use the same driver on Windows and on a Mac, even if they were talking to the same database. Net Protocol All Java, on the other hand, implies that we can use this driver on any system, our famous write once, run anywhere. But unlike the first 2 or the last, the Net Protocol driver does not communicate directly with a relational database. Instead, it's designed to communicate with what's called a middleware server. A common use of such a server would be to, upon receiving a request for data, determine which physical database server is most appropriate to handle the requests of the user. This middleware server would in turn be communicating with the actual database, retrieving results, and then returning them to the end user. This type is still found in environments where there are multiple servers serving the needs of customers and employees. The last is the native protocol. We also call that the Type 4 driver. This is what we're using. This is a driver that handles all aspects of communication between your application and the database. There's no need for any additional components, and exactly the same jar file will work on Linux, Windows, a Mac, or just about any other platform that supports Windows, or supports, Java. So let's begin. First thing we need to do is establish a connection. So here we see a connection, and I should tell you that the Waldo server no longer exists, so don't try and run this on your own. The first thing we need is what's called the URL. We need the address of our database. We can see that there are a number of different pieces of information in this URL. The first says JDBC. This defines the protocol. In other situations, you may see protocols such as SMTP for talking to a mail server, though luckily we have JOD to hide that complexity for us. So JDBC isn't the only protocol. The next piece that says MySQL, this tells us the specific database that we're going to be working with. This is critical because at runtime, your application will read this line of code and determine which JDBC driver it requires. In this case, it's going to require the MySQL driver. It then must be in the class path of your application. But of course, we don't worry about that because we have Maven taking care of that for us. After MySQL, we have the address, the location of the database. It can be, as we see here, as a domain name, or it could also be its IP number. After the colon, we see the port number. Now, 3306 is the default for MySQL. After the slash, we see the name of the particular database. So in this case, it's the aquarium database. Very shortly, I will be giving each one of you a database on Waldo. And so if you were using that rather than a local database, you'd replace aquarium with the name of your database. Two more pieces of information we're going to need to make our final connection, and that is the username. So in this example, it's the silly word fish, and then followed by a password. Remember, passwords should be difficult. Don't make them too easy. There's a lot of software out there that just very quietly tries every IP address and every port and tries to figure out what it can find and what it can get into. So here's our code. First of all, we place the code for connecting to the database in a try with resources. You're all familiar with try catch. In the try, you put code that could throw an exception, and in the catch, you handle it. Starting with Java, I believe it was 1.7, a new style was introduced. The try with resources gives us a block right after the try within parentheses rather than braces. Within the parentheses, we are allowed to initialize, instantiate objects. So we can see here that what I'm instantiating is the driver manager object called connection. And you see I'm passing it the URL, the user, and the password. The significance of try with resources is the fact that it's necessary once we're finished working with the database to disconnect. Databases work very much like a telephone conversation. Once you connect, the line remains open. And any database has a finite number of connections available. So ideally, you want to make your connection, retrieve the data that you want, and then release the connection. When you release the connection, you're required to close the connection. With a try with resources, code within the parentheses. So in this case, we're looking at the class connection, must be implementing something called the closable interface. This means that when the entire try block finishes, or even if an exception is thrown and we jump to the catch rather than just finishing the try, the close method of connection will be called. It effectively makes it impossible to forget to close, to leave, as I used to say when I was a young man, leave the phone off the hook. Try with resources eliminates that. Remember, though, that we can only create objects either using new or using a factory method that we see here, and that class or that object we create must implement closable. Any actual code or manipulation is going to happen within the braces of the try-catch. So, with our connection made, it's time to talk SQL. So here we see a nice simple query, select star from fish. You can pretty much figure out that this is going to retrieve all the 200 fish from my aquarium database. And now we see how we've added to my try with resources block. There's my connection, but now I've added two more objects that I am creating. Again, all three of them are created by factories. They're not created on their own. So we have our connection object, then we have our prepared statement object, and finally the result set. Connection dials the database, prepared statement transmits the query to the database, and execute query has the query run on the server and the results return to the result set. Well, once we have a result set, it means that it's necessary to retrieve the data and place it into our beans, into our objects. So here we see, well, I create fish data. So I create an object, and it has a default constructor that makes sure that everything is nice and empty. And now I proceed to retrieve from the result set object each of the fields. JDBC allows us to refer to a field by name or number. The best practice is always to use the name. And to avoid issues with when something is case sensitive or not, it's always a good idea to name all your fields either all in uppercase or all in lowercase. No camel case or anything else, because people will always get it wrong if there's some mix. So here we can see I'm calling the matching set method of every single field and storing the information that came from the result. We're using the prepare statement, and this, well, it creates a prepared statement object. What it does is, when we execute it, is it retrieves the result set in such a way that we can process the result set. Remember, the result set is a reference to one or more rows in the database, actually 0 or more rows. It is perfectly acceptable. It is not an error to issue a query for which the criteria results in 0 records selected. Just means you didn't find anything. It doesn't mean anything's wrong. By default, this creates what we call a forward only, meaning we can move forward from record to record, but we can't move backwards. And the result set is read only. We cannot edit the data directly in the result set. That's one of the reasons we move these queries and we transfer them into a data structure, into one of our beans. So here we see, after retrieving the result set, I have a while loop. RS next, RS being the result set, advances through all the records retrieved. An interesting thing about how next works is it begins by pointing not at the first record, but to an imaginary record that exists before the first record. This imaginary record will always exist. Now, the first time I say next, I will advance to the first real record. Or, if no records were found, no advance happens, and you can see that rsNext is in a while, which means that its return value has to be a Boolean. We will loop through the result set as long as next can move to a subsequent record. So this ensures that we process either no records because none were found, or only as many records as are available through the result set. It is possible to return a live result set. It is possible to actually edit data in the result set and have that written back to the database. This is not a technique we're going to use. It can make sense in an application where you are not sharing the database. But once you are, you want to take the strategy of connect, get your data, move it into your beans, and get out. Here we can see how we could create a connection or a statement that does allow us to either update or scroll. So type scroll sensitive means that not only do we have a next method on the result set, but we can also move backwards. We can back up. And concurrently updatable, that's actually interesting. This means that if someone else is looking at the same record and you change the record or they change the record, your result set will be updated automatically. You can see here from this chart the number or the choices available to you. Forward only, which is the default. Concurrent read only is also the default. And then you have the choice of insensitive or sensitive, or whether or not it's updatable. When we create a query, we want to use, first of all, the prepared statement. There is a class in JDBC called statement, but statement should never be used because it is a subject or cannot deal with one of the most common tricks for breaking into a database, and that's SQL injection. SQL injection involves putting an SQL statement as a value in a field. So if you fill out a form and it asks you for your name, you might say that your name is select star from salaries. And in the case of a statement, this inner select statement could execute and could reveal information it shouldn't. A prepared statement, on the other hand, does not allow such a embedded SQL statement. It will block it, but only if it's done right. In the string concatenation bad, we see an example of creating an SQL query in a string by concatenating a value into the string itself. So we see select banks from loan where loan type equals, and then we concatenate loan type, which we can imagine represented a field in a form or possibly a value from a database. I said earlier that prepared statements prevent embedded SQL, but not if the embedded SQL is concatenated to the statement. So if loan type, a string, contained a select statement, it would still probably execute with our prepared statement. The second example, the parameterized good, shows us the proper technique. We can see here that our select statement, rather than using concatenation, uses a question mark. Let me move myself out of the way here. This question mark is a placeholder. The question mark is the only symbol or character we use. Next, I go off and I get that loan type. So we're assuming it came from someplace in our program. I prepare the statement, I pass it the query, but remember the query is what we see up here. We see the question mark in that query, so it's not going to include the information we need. It's the last line that's the key, the p statement dot set. The number tells us which question mark, and question marks are counted starting at 1, and then the value we wish to set. Using this method results in the prepared statement validating the string. And if the string contains SQL syntax, an exception will be thrown and the SQL injection will fail. So this slide just goes over what I've said. The key here is only use prepared statements. Never use the plain ordinary Java statement. Here again is another example where we have as our question mark code equals. Similar to the first example we've seen, though in this case I say set string and I'm indicating the name of the field that has a question mark. So if I don't like numbers, I'm allowed to use words. Here we have a more complex statement where we have multiple question marks. We have a value for description. We have a value for price. We even have a value for code. So now we're going to set the string for these 3 question marks, retrieving the information and then executing. In this case, this is an update statement, so we use execute update. If it's a select statement, we're just using execute query. To insert a record, really all that's changing between these examples is the particular verb, in this case insert, and using its proper syntax of listing the fields followed by the question marks. Deleting a record, same idea, though always watch out for deleting. Notice that in my execute update here, I have the number of records. Select statements return result sets. Update statements return an integer, the number of records. You should always examine the return value from an execute update. There's nothing worse than working on a problem. You think you're going to be deleting a single record when you look at the value for records, you just discovered you've deleted 10 million records. Well, if that happens, you should probably start brushing up your CV and get ready for a new job. Or, as we'll learn next semester, we'll learn about transactions. So that if you issue a silly command that deletes far too many records or updates too many records, well, you can roll back. Now, when we're working with a result set, let's move myself down here so we can see the text. When I'm working with a result set, when I'm issuing a select, I have to match the primitive type with the particular SQL type. There are also certain objects that I can map, things like dates and times, and one of the more interesting types of objects are blobs and clobs. We'll look at those on Friday. So here you can see how we can retrieve a particular type from an SQL database. We have a get, and then we have the matching class type. There's a chart at the end of these slides that shows you all the different types available. Notice that you have both get with a column index or a column name. The column index is always preferred. So, we want to retrieve data. I use the appropriate get. Maybe it's get int, or get long, or get string, or get date, or get time. Aside from the actual records from the database, we have a second category of information that we can retrieve, and that's called metadata. Metadata is best described as data about data. In the case of our database, things like the names of columns, how many columns, even the data type for a column is considered metadata. Once we retrieve a result set, we can then, from the result set, retrieve this metadata. Here you can see some of the questions we can ask. For instance, how many columns did we have? What's the name of a particular column? Now, the name of the column will match the name from the SQL create statement. But notice next comes column label. In this case, it's possible in some database programs to have two names per field. One, a basic name, no spaces, no funny characters, but the second name can have spaces and just about anything you want. The label is likely to be used in reports. I have column type. If I want to know the integer that represents a particular type, or in the last example, get column type name, where I can actually get a string that tells me what the SQL data type is. So let's look at this example here. I'll just, can't move myself too far out of the way. I'll stay down here. So I have an array list of strings, and I have a method called getColumnNames. GetColumnNames, that's my method, receives a result set. So we can imagine that somewhere else in this class, in another method, a result set is retrieved. I go off and I create an array list, initially with nothing in it. I go off and I retrieve the metadata. Something to remember, if the result set is empty, there is no metadata. So you should not look for metadata if you couldn't, or if the result set had no fields or no records in it. We get the metadata, and in this simple example, I'm simply retrieving the names of all the columns and stuffing them into my array list. Well, before we go any further, let's take a look at a real example of how this all comes together. So I'm going to leave this here, and let's switch to NetBeans. Here we are, and I'm going to look at an example called JDBC Demo. It's mentioned in the Moodle references. So we'll open it up, go into its source packages, and we can see we have a bean. So here we go, the famous fish. Here are all the fields. Each of these fields match, and fish is a simple example because everything's a string except for the primary key. I have a non-default constructor. This is convenient for creating objects using the constructor. This is more and more a common way to create objects, especially as we are creating more immutable objects. Objects that effectively do not have set methods, only get methods. Therefore, the only way to place data in them is through the constructor. Of course, we want to respect the specification for beans, so here we have the default constructor. I set the ID value to -1. I do this so that I can recognize that this particular record has never been persisted into the database. and then I simply create empty strings for every field. Next, the usual suspects, the gets and sets. And in this case, I have my toString. The funny spacing here is just so that when this string is printed, it comes out looking pretty. We don't see it here, but we'll see it when we run the application. Here's my hash code. This particular method was generated by NetBeans. Eclipse will do the same thing. And my equals method. In this example, I do not have a compare to method because I see no situation where I would wish to change the order or sort the database in memory. If I want a particular order, I'll use SQL to return a result set in the order that I want. So there's my fish data. Next, let's take a look at the persistence. And if you notice here on the left, there are two classes. Actually, the first class, FishDAO, FishDAO is an interface class. We want to employ interfaces wherever possible. Not every class is going to have an interface. Beans certainly never have an interface. But an action class or a business class frequently will. This allows you to write code to the interface and at the same time allows you to change the implementation without having to update any of the other code. So we can see here the particular methods that we plan to implement. We have a create to create a new fish. If I want to retrieve all the fish, I want to retrieve fish by an ID, and notice that this one returns just a single fish data object. Or maybe I'm interested in the diet of a specific group of fish. This too will return an array. I have an update if I want to edit the value, and finally I have a delete. The implementation for all of this happens here in my implementation class. You can see here that I'm importing the SQL library. So, well, there's my logger. Remember, we love loggers. Then I have with the logger out of the way, the next three fields, of course, are the necessary connection details to our database. Yes, I recognize that the username and the password both say fish, but it's probably the only way I'm going to remember what they are every time I present this lecture. Please never do this. So let's take a look at the different methods. Let's begin with find all. So this is a simple one. It says, well, I create an array list. This will be empty. I have my query, and the query's quite long here. Now, I know some of you are looking at this and going, how come he didn't put star? Well, there's a great deal of discussion about whether or not you should be using select star. The feeling is using star means that you're not really aware of all the necessary fields or all the fields that you may be retrieving. The best practice is to list every field by its name. Granted, if you have a database with 100 fields, well, I'd probably use the star if for some reason I wanted every field in a report. But in almost all situations, you prefer to use the field name rather than a star. Here's my try with resources, where I go off and I make my connection. I send the query into the connection, and then I execute the query. In this example, there are no parameters, there are no question marks. Now, with my while statement, I take a look to see if there are any records, and for every record I find, I call this convenience, this private method called createFishData. Let's go down and find that quickly. Oh, there we go. So createFishData allows me to take the current row as passed as a result set and place it into a bean. This bean in turn appears, whoops, let's get to the right one here. This bean is then added to the array list of rows. So when this method finishes executing, we'll have an array list of 0 or more records. Also notice the use of the throws clause here. Remember something we've talked about. A big question in writing code these days is, where do you handle an exception? Yes, an exception could happen here, but if it does happen here, this is not where we're in a position to notify the user or carry out any corrective action. Instead, we need to pass this exception up to whoever called upon findAll. They're in a better position to determine what action to take. So you'll notice that in all of my implementation code, they all throw an exception. Here we have find by ID. This one, and the difference is that if we look at the end, we have a prepared statement parameter. We have the one question mark. That question mark will be mapped to the ID that was passed into this particular method. So here we go. There's my connection. There's my prepared statement. But we have an interesting problem now. Before we can ask for the result set, we have to set that primary key value. But this is not a statement that is allowed in a try with resources. Therefore, we actually have to end the try with resource. So there I have my closing parentheses, which matches the opening parentheses, opening brace, and now we say set int. But the next thing we want to do is create a result set object. We need our try with resources, so we use an embedded try, a second try, the try inside the try, where we create the result set. This try with resources ends, and now we get into the code. In this case, we look to see if there's a next. Because we're searching by ID, because we know that as a primary key there can only be 0 or 1 record found with that ID, I don't need a while loop. I just need to see, can I advance from the imaginary record to a real record? And if I can, well then off to my private createFishData, and now I'll be able to return the single fish with that ID. Finding the diet is very similar to finding all, except, again, we have a parameter for our prepared statement. So we make our connection, we create our prepared statement, we end the try with resources. We do our set. We create a second try with resources. And this time we go back to a while loop, because it is conceivable that certain fish will have more than one, or there'll be more than one fish that's an omnivore, a carnivore. Heck, there's probably a few vegetarians in the group. There's my private method. And finally, we get to create. Create uses an insert statement. And so here we can see a whole family of question marks. So we go into our try with resources. We create a connection. We create a prepared statement. And then we end. because the sets, all the values that we're placing into the insert, cannot be in the resource portion of the try. Now, with everything in the query, I'm able to execute the update, and I get my result. Notice that in executing an update, result in this case is the number of records that are found. Or excuse me, not found, but the number of records that are created. The assumption is this value should probably only be 1. Now, this last section here, and this is where I actually ended the slides because I wanted to talk about this issue here, deals with primary keys. In this particular database, we have instructed MySQL to be responsible for creating the primary key. So every time we add a record to the database, the key is assigned on the server, not in my code. But I'd like the record that I just created, that I just inserted, to include the record number. So here we see the necessary code to do this. First, we need a result set, and we ask for something called getGenerated_keys. It could return more than one generated key if the particular statement was inserting more than one record. I have a variable called record number. This is where I wish to store the information. And again, I'm assuming that I'm only inserting one record. And then I use a next. And because the primary key is an integer, I just have to say rs.getInt1. With this carried out, I will now have the primary key value that SQL assigned, and we can see here on this line that I can now store that value into the record. If I did not have this capability, I would have to retrieve the record from the database after I wrote it to the database just to find out what the primary key is. Here, I'm able to use this getGenerated_keys to just get the last key generated. This particular command is perfectly safe. It remembers keys for you so that other users working with the database concurrently, there will be no conflict. You will not be getting anybody else's keys. Here we have our delete, as we saw in the slides, pretty straightforward. Notice that I have my result, and that is the value that's being returned from the delete. I should, when I get this value back, verify that it is 1 or 0, and certainly not some huge number that implies I've just deleted the entire company database. And my update, well, I'm just using the update syntax where the question marks appear after each of the field names. And as we did for our create, in the resources section, I create a connection, I create a prepared statement, and then I'm finished with resources. It's set. Oh, one thing to note, there's one thing I'm not setting here, and that's the ID number. That's the value that's being generated by MySQL. Issue my update, and again return the result. Certainly the expectation is that the value I receive here should be 1. Any other value would indicate an error of some sort, though most errors will be picked up by my throws SQL exception. In your testing, I suggest you try, for instance, for the common name, having it as an SQL statement so that you can observe what happens when you attempt SQL injection. So let's see how this program works. Let's run it. right mouse click, custom, I've already set it up, JDBC demo, so it will clean, it will build, it will run some tests, and then it executes. What we're looking at is a simple JavaFX stage. We use the word stage rather than window now. We're now very fancy programmers. And inside this stage is something called a scene. And inside the scene is a text area. Very similar to the same text area that you'd find in Swing. You may have used that in your previous semester. The way in which these individual records appear are a result of the toString method. So here are my 200 fish. One last thing to talk about in terms of how this is managed. So I have my persistence layer. The persistence is talking to the database. I have my beans, and here's my presentation. But rather than having the presentation layer talk directly to the database, I've introduced what in this example is called the business layer, and I have a class called Fish Manager. The Fish Manager, which is a very simple class in this example, is where the individual actions begin. So if I want to retrieve all the fish, I have a retrieve fish. Or retrieve, well, basically any kind of fish I want, but in this case, notice that I'm only looking for find all. This is where the SQL exceptions arrive. It's here that I can decide what, if anything, I should do. Normally, the Fish Manager is accessed by the presentation layer, and values that are returned allow the presentation layer to either display the proper information or display some type of error dialog. Take a quick look at the display method or the display class. This is an FX application. All FX applications extends application. All FX applications must have a method called start. And in this simple one, I create a text area, and I call getTheFish. GetTheFish was in my Fish Manager. This will return the string that text area can display. No word wrap, set the size, and then here is what I consider to be the coolest thing about working with JavaFX. We can use CSS. Not everything in CSS works in JavaFX. In this case, for instance, we've actually embedded the CSS using setStyle, but the CSS could also be in a separate file, the same way we work with it when we're dealing with web pages. I create a scene, so I'm placing the text area in the scene, and then I put the scene on the stage, set a title, center it in the middle of the display, and then I show it. Here's my getFish, create the manager, retrieve the records, and here I start looking, well, what happens if, well, as long as it wasn't null, and I had more than 0 records, let's get these records back to my display. Otherwise, I have a message here that says no records to display. The main in a JavaFX application is the smallest possible main, just the command launch. That is an uppercase L, and this launch with the args, so we're taking the args from main, is what activates the JavaFX framework, and away we go. Let's look at this one more time. And there's all my fish. Of course, I need to test this. So let's take a look at my test packages. Here we have Fogel JDBC unit tests. Let's open it up. There's my demo test case. So I have, well, the test case also contains the necessary information to connect to the database. Right? We saw these same fields. Let's take a peek over at my implementation. Now, in this example, I am talking to a particular database. In the demo class, notice that I have the root user and password. That's because one of the things I'm concerned about when testing, especially in a database, is what happens when there's a destructive test. A destructive test changes the state of an object, or in this case, a database. So I know I have 200 fish. What if I decide to test if a delete is successful? So I would delete a record, and then I could either try and retrieve it, and of course I would return a result set of a length 0, or I could just ask how many records were there, and if there were 200 and I deleted a record, there should now be 199. But this also means that after I do a destructive test, any test that expects there to be 200 fish is going to fail because my destructive test changed the state of the database. I overcome this problem by using a routine down here in before. I want to point out that I'm not the author of this. Bartosz Majczak, I'm not even sure if I'm pronouncing it right, though I am going to meet him for the first time here in San Francisco. He works for Red Hat, and he's a developer for a tool called Arquillian that we will use next semester. When I first started working with Arquillian, he assisted me in getting it configured, and he also provided this nifty little routine, the seed database. What it does is it reads from an SQL statement, so create fish MySQL. We'll find it over here. Let's see, is it in other sources? No, it's in my test sources. There it is, create my fish. It drops the database, creates the database. I need to be the root for this. I then grant privileges, and I go off and use Aquarium. Now, I don't really have to do all of this. Because I will give you a database on Waldo 2, you will not be able to run these first 4 commands. Instead, your password, your username will be pre-configured. You will use just the drop table if it exists. As a user of a database, you can't create databases, but you can create as many tables as you want. So I drop the table, and there's my insert statement. The auto increment is what tells us that this is a primary key that will be generated by MySQL. Oops, I forgot. Let's go back, because what follows is the 200 fish. When using this technique to insert a lot of records, keep an eye out for unusual characters, accented characters. They can sometimes be a problem in your insert statement. So, back to demo test case. So, this little routine loads that create statement, makes a connection to the database as a root user, and then proceeds to execute the statements one at a time. Our enhanced for loop splits, retrieves each line of the SQL statement. And we have the supporting code, private methods, that perform this for us. Now, every time we run a test, so let's do find all, before this test runs, the database is recreated. Therefore, we should have our 200 fish. Test find by ID. So I know what fish number 6 is. So I create an object that has the data I know should be in the database. I then go off and create an instance of my fish DAO, and then I retrieve ID number 6. Remember that my fish data had a equals and hash code, so I can now compare these two records, which means the equals method will be used, and if record 6 is what I think it is, this assert should be successful. I have some other tests that I have not implemented. When I ask NetBeans or Eclipse to create a JUnit test, it will ask me what class I'm testing, and it will proceed to create a method for every unit I need to test. This is what it looks like, and of course they all fail, and since I hate failure, I've placed an ignore in front of each of these tests. Remember that if we were doing something like test delete, a single deletion does not prove that your code works in all cases. A deletion usually involves providing a primary key. You need to know what happens if you use a primary key that doesn't exist or an invalid primary key. You're not going to find record -2. So in many cases, there might be test delete 1, test delete 2, test delete 3, or better yet, test delete with valid ID, test delete with invalid ID, test delete with ID known to be not found. Yes, I know the names get a little long. And we're back to our seed. So there we go. This application gives us our first look at using JDBC, but again, I'm assuming that this is all a review, and the most you're getting out of this is looking at my style of coding, the fact that I like to see an interface, that I like to see try with resources used. And again, if we go back to the application and I run it, I get to see all my fish. So, where does that leave you? Well, you have your mail module. It's able to send and receive mail. The first thing you need to do is to create the appropriate SQL statement, the create statement, so you can create a table that matches your particular extended email or received mail objects. You need to write the appropriate methods to store this information. So if I pass, for instance, the Ken Fogel email object, which extends the regular email object, I will need methods that can retrieve the necessary information so that it appears in the appropriate set method when I'm inserting or creating or even deleting. And at the same time, I'm going to need select statements, different types of reports. I'm going to need to be able to not only ask for all the records that follow a certain ID, of which there'll only be one, but we know, for instance, we need to find all the records from a particular folder, or maybe we want to find records from a particular from. So what you're going to be doing as part of the next phase is creating the database module, taking a close look at what you feel you're going to need to be able to retrieve emails to display, store emails that you've created and have been sent, and, as you know, the appropriate test units. So that's it for today's lecture. On Friday, we'll look a little deeper into database and cover some other topics. And, well, I'm still asleep here in San Francisco, so I'll see you next week, and I'll see you on video on Friday. Well, here I am. I thought you'd want to see me full size. And I'll see you in video on Friday, and I'll see you in class next Tuesday. Bye for now.